Chapter 8-3, Angle Relationships. Perpendicular lines. The angles formed by two intersecting lines are equal to 90 degrees. I can have perpendicular lines meet at corners called vertexes as my rays continue out. I can also have perpendicular lines that intersect each other, going on, of course, in both directions forever, and each of these will form a 90-degree angle. Our next word is parallel lines, lines in the same plane that do not intersect at all. And we're all familiar with parallel lines. They continue on in both directions, never touching. There's another pair that can go vertically as well as horizontally. Our next word is new to us. It's skew lines. They do not intersect and they are also not parallel. They lie in different planes. As you remember, a plane is a flat area that continues out in all directions. It has length and width, but it doesn't have height. So you have two planes here. This plane is on top, our plane Y, X, W, and Z, and our other plane is beneath it. V, U, down here. These other ones don't really have names, do they? So you can tell that if I were to highlight line YV, it will never touch line WZ. Line YV is behind, and it will go up and down behind like the back wall of a room, and WZ is in front like the door that you're going to be walking into, the wall on that. So those are skew lines. They will never touch, and they are not parallel. Our next definition is adjacent angles. And adjacent means to be next to something. So angle 2 is adjacent or next to angle 3. They have a common vertex. Here's our common vertex and side. There's our vertex. But they don't have any interior points. They're not overlapping. So they just touch each other and have a common side. Now our next definition, vertical angles are the opposite angles formed by two intersecting lines. Vertical angles have the same measure, so they are congruent. You'll notice angle 1 and angle 3 are across the two intersecting lines. They look pretty acute to me, so I'm going to say that they're 30 degrees. So if angle 3 is 30 degrees, angle 1 is also 30 degrees. Vertical angles are equal or congruent. So let's now look at angles 2 and 4. 2 and 4 are vertical angles because they're across the intersecting lines. Now it looks pretty obtuse to me, so I'm going to say it's 150 degrees. So if angle 2 is 150 degrees, angle 4 would also be 150 degrees. And if you'll notice, we made a straight angle here, and it totaled 180 degrees. So there's many ways to figure out the measures of angles. If you know one, you can figure out the other. And that's what we're going to do in this figure below. We are going to be talking about a transversal. A transversal is a line that intersects two or more lines. So if we're looking at our figure, I would say that line T is a transversal. It is cutting through two lines. These lines are also parallel. Corresponding angles are on the same side of the transversal. So here's our transversal T. Angle 2 is on the right, angle 4 is on the right, angle 6 is on the right, and angle 8 is on the right. We're looking at the right, and now we're looking whether it's above or below the two parallel lines. Angle 2 is to the right and above. Angle 6 is to the right and above. So those two angles would be the same measure. Let's look at the ones below. Angle 4 is to the right and below. Angle 8 is to the right and below. Those two angles would also be equal. Another set of angles that are equal would be 1. It's on the left and above. Angle 5 is on the left and above. They would be equal angles. And our last set of equal angles would be 3. It is to the left and below. And 7. It is to the left and below. So now that we can look and find angles and their vertical partners or their adjacent partners, we can figure out the degrees in every single one of these angles. We know the measure 50 degrees. If we think about vertical angles, the angle across from 50, we know that angle 5 will be 50 degrees. They are vertical angles, so angle 5 would be 50 degrees. We also know this angle is 130 degrees. So if this is 130, his vertical partner would be 130 also. So angle 2 is 130 degrees. Let's look at some other pairs. So I'm going to relabel this as 50, and we know this is 130. So let's talk about angles along this transversal. This 50 is to the right and below. The other angle that is to the right and below would be angle 3. It would also be 50. And if you notice, if I add these two, there's our 180. So angle 3 is 50 degrees. It was to the bottom and right, bottom and right. So if we know that this angle is 50, how much do we need to get 180? 130 degrees. So angle 6 is 130 degrees. Let's clean this up a little bit. We have an awful lot of stuff in here. So we have 130, we have 50, we have 50. Looks like everybody's going to be either 130 or 50. We don't know angle 1. If I look at my vertical angle, if 3 is 50, then 1 has to be 50. And that gives me my 180 degrees on my line. So we're left with poor angle 4 here. What is angle 4? Well, I can do it two ways. I can look at the 130, and since I have a vertical, this would also be 130. I can look and see what makes 180, and I know that 50 plus 130 equals 180. I could also look at those angles that are across the transversal, to the left and below, to the left and below. That also makes me know that that is 130 degrees. This was Section 8.3, Angle Relationships.